Hi folks, Mr. Long here again. I'm going to do a limit today of quite a complex fraction, and we're going to use the fraction rules that we've already learned. Some of the fraction rules go right back to grade 7 and 8. Some of them you learned in 11U when we simplified fractions. So it's all about getting common denominators. It's all about recognizing situations that have 3-layer or 4-layer fractions. Okay, and that's the limit there. It does look really challenging, but I think you're going to find it's not that terrible. Okay, so you will have there's a copy of this somewhere within the lesson materials, and so you'll have a copy of this that you can annotate. There'll be a blank copy as well that you may want to do a full solution on yourself. Okay, folks, so again, we're doing limits, so I want to find out what happens to this crazy function when I get really close to -2. Okay, when I get really close to -2. Now, one of the things I'm going to need to do here is substitute in -2, right? I'm going to have to substitute in -2. Now, one of the things I would do, if I saw x squared plus 5x plus 6, I know it has to add to that. Actually, let me put that here. It has to add to that number and multiply to that number. So, you know what? That's a pretty easy one to factor. So I'd go x, two numbers that multiply to 6 and add to 5, x plus 2 and x plus 3, right? I know that. Okay, so now let's start going through this and seeing what happens if I sub in -2, right? And you don't have to do all the calculations. You just have to know if it's 0 over 0 or not. Because if it's not 0 over 0, you get to stop and, and just put in the answer. So right here. So the first thing I'm going to do is I can see right away, I look at this x plus 2 and I go, oh, if x is -2, I'm going to get 0. Okay, so if x is -2, I'm definitely going to get a 0 on the bottom. Now, is that enough to know that it's indeterminate, 0 over 0? No, because if it was a vertical asymptote, it would be some number, okay, some number over 0. So it would be a number that's not 0. So it would be like 5 over 0. So that would be a vertical asymptote. But we're not looking to investigate vertical asymptotes at this time. We want to see if there's point discontinuities. So I'm going to have to sub in x equals -2 on the top as well. Okay, so -2 there, -2 there. Just sort of cross those out so I know it's -2. Well, what does this little fraction work out to? -2 minus 3 is -5, so that's -2 fifths, right? -2 fifths. And then I look at this little fraction over here, and I've got -2 plus 4 on the top. That makes 2, and the bottom is 5. Well, look at that, would you? -2 over 5 plus 2 over 5. There we go. That's 0. So I have a 0 over 0 scenario. Okay, 0 over 0 scenario. What's that mean? That means it's indeterminate, cannot be determined. There is a hole in the graph, or a point discontinuity, or a removable discontinuity, it's called. 3 different names. Okay, so I'm going to erase this because we're going to have to look at this in a little bit. Now on a test, you wouldn't want to erase that. You'd want me to see that work. So here's what I need to do. I look at this and I go, okay, now this part here, I should put here x plus 3, x plus 2 for sure. Now this part here, I need to simplify that first, right? I need to simplify that fraction into a single fraction. And so we have to get a common denominator. Now what I'm going to do is I'm going to come over to here, and off to the side, I'm going to simplify the numerator. Okay, simplify the numerator. So I know for this one that the common denominator, so again, this is the numerator. I'm just simplifying the numerator right now, and I do it off to the side, okay? It takes place, I don't want to put it in the limit because there's going to be so much work showing that I might lose track of where I am in the limit. So I do the simplification of that fraction that's inside the fraction off to the right. What's the common denominator? 5 times x minus 3. What does that mean? Well, I've got to multiply the 2 by, this has to be multiplied by 5 over 5, right? And then the x plus 4 has to be multiplied by, I'll do this in red, the x plus 4 has to be multiplied by x minus 3 over x minus 3. Okay, and we've been doing that stuff for a long time. Okay, so I do that. and I've got lots of work to do to simplify it. This is pretty easy, right? 2 times 5, that's 10, check. Then I have to do x minus 3 times x plus 4, yuck. Although, it's a nice easy one because when the coefficients are 1, remember what we do. If the coefficients are 1, I don't have to do FOIL or draw the grid and expand through the grid, the box method. I can just do x times x is x squared, check. Then it's negative 3, which would multiply by x, and then that plus 4 would multiply by just 1x. So the x term is just going to be negative 3 plus 4, 1x. Then I do the last term, which is negative 3 multiplied by 4, which is negative 12. Then I have, my like terms are right there, 10 and negative 12, and that works out to negative 2. Let's see if it factors. Okay, does it factor? And so I've got x squared plus 1x plus 2. So it has to add to this, multiply to this. Are there two numbers that multiply to negative 2 but add to 1? Pretty sure there is. Negative 1 and 2. Okay, negative 1 and 2. So I've got it in factored form now. Okay, so that process is simplifying the numerator. Now what I do is I take this thing here and now I put it back into the limit, okay? And so I start working in the limit again. Okay, I'm putting that back into the limit. So this right here is just worth this in a more simplified form, okay? Now I've got what's called a 3-layer fraction. There, over there. So it's a over b all over c. So 3-layer fractions have two forms, okay? Two forms. One form is where you have a smaller fraction all divided by c, or you can have the number a divided by a smaller fraction of b over c. Now, what I'm going to do here is do a numerical example for you. So if you had, let's see, 1/2 divided 4 ways, right? So if you have a half of a pizza, and if you divide it into 4 parts, you divide it into 4 parts. 1, 2, 3, 4, and you have one of them, okay? So 1/2 being divided 4 ways. It's 1/8. We know that, right? It's 1/8. So 1/2 divided into 4 parts is 1/8. Well, what it really is 1 over 2 times 4. Okay, so if we look at the formula here, look at this. If this is a, b, and c, I know that it just equals a over b times c. Okay, so that's a formula I can use. Now it's better to understand it, but I can use this formula here, right? So if I have a over b as a smaller fraction, all divided by c, it becomes a over bc. On the other hand, what about this one? Okay, what about this one? I want to make sure you understand this. Operations with fractions are so critical, and they're not easy. So now over here I've got a over b over c. Well, here, what if I had, let's see, what if I had 2 divided by, say, 1/4? Okay, well, I can think of this as how many times does 1/4 go into 2? How many times does 1/4 go into 2? Oh, 8. Okay, 8. And I'm doing this, I should take more time with this stuff, but, So if you kind of look at that, you can see where the heck does the 8 come from? Clearly I'm multiplying 4 and 2. Okay, so it's going to be 2 times by 4, actually divided by that 1. Okay, divided by that 1. And we can look at this, no, you know what, I'm going to stop there. So then what that becomes is, if you look at this, there's your A, there's your C, and there's your B value. Okay, so it becomes AC over B. Okay, so which one do we have? Which one do we have? We have, to me it looks like A over B right there, and then all divided by C. Well, look at that, would you? Looks like we have this scenario, okay, this scenario. So that becomes A over BC. Again, you can do the invert, like you can if you want, you can go like this and go, okay, I'm going to do over 1 and I'm going to flip the bottom and multiply. I can do it that way. Or I can just recognize it's A over B all over C, and then that's A over BC. Okay, so what I do is I just write it that way. There's your A, right? And then your B is right there. And your C is right there, okay? A over BC. There's B, there's A, and there's C. And at this point, we can start, oh, I've got a St. Bernard beside me that's, I think, about to start barking. Okay, so now what I need to do is simplify, right? Can I simplify anywhere here? Well, look at this. I've got, oh, look at that, x plus 2 divided by x plus 2. Whoa, wait a second. What does that do for us? Look at my limit. I'm trying to get to x equals negative 2. And that's why it has to be a limit. I can't get to x equals negative 2. I can't, a limit means I'm trying to get really close to it, right? And I have to keep it as a limit until the instance in which I don't have to just approach something. I can finally get there. So if I look at this, can I get to negative 2 when the x plus 2 and x plus 2 are there? No, because that's what causes the 0 over 0. 0 over 0 is removed as x plus 2 over x plus 2 equals 1. Okay, that's gone. What's left over? That right there. Now, I'm allowed now to get to negative 2. I don't just have to approach it. So at this point, I drop the limit because I can actually get to x equals negative 2. And what I do is I replace this x with negative 2. Negative 2 minus 1 is negative 3. And then I can replace that x with negative 2. Negative 2 minus 3 is negative 5. I replace that x with negative 2. Negative 2 plus 3 is 1. Okay, and then I end up with, when I multiply it out, 3/25. So what does it mean? Well, it means that if I'm at an x value of negative 2, right, I go up and I hit the curve and I come across, the y value would be 3/25. Okay, so you're going to have a copy of this, the completed example. You'll have a copy of a blank one for you to annotate yourself, and then you'll have a copy of an original with just the question that you try and solve yourself. Okay, so and then you have some practice questions to do. So good luck. Pause, rewind, go over this video as you need to, and have yourself a good day.